Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is a similar installation like before, the similar problem. The only difference is that elevator is accelerating down with A1 and A1 is the same, 5 meters per second, right? 5 meters per second squared. So it's accelerating down. And the same force, 2 or 4 newtons, and they want us to find out what's going on here in this scenario. And so let's solve it. This would be exactly like before, so I didn't wipe it out. This is always the case. The sum of all forces equal ma, and those are all vectors. So mg, n, a friction, F equal ma. mg, n, a friction, F equal ma, and those are all the forces whom this body is interacting with the Earth, so gravity, whom this body is interacting. It's interacting with the surface. Surface creates two forces. One normal projection and another is horizontal projection along the surface, and external forces also pushing. So this is all forces. Axis xy, projection on x, those two n and g, they have no projection on horizontal axis, 0, 0, friction is this, minus F equal ma2 that we want to find out. And the only difference now would be that here mg is down minus, n up plus, two zeros because F friction and F projection on y doesn't exist. The only key is ma. ma is directed down. They told us a is directed down, but we had chosen to put the axis y. If we would have put the axis y, it would be positive, this would be positive, that would be negative, it would be the same absolutely equation. But if we put axis this way, we put this with minus, this with plus, and we have to put this with minus. Minus m and 1, and from this equation it would be minus here. So the critical friction in this case would be mu n. It's the same like always, critical friction. F friction mu n, it's critical. F friction 0, I don't know, mu n. And it would be mu m g minus a1. So I put mu, and instead of m I factor it out, and I put positive first and negative later, and I received m, and I receive the numbers here, 0.3, 1, 10, minus 5, it would be 0.3 multiplied by 5, it would be 4, 5 multiplied by 3, it would be 15. 1.5 Newton, right? And that's the case. So n suddenly dropped to 1.5 Newton. So when we were standing still, n was 10 newtons. And here it's 1.5. When we were in the beginning, the mass was 10, so this was 3 newtons. When acceleration was A2 was 0, this F friction was 3 newtons, the very first case. When acceleration was up, F friction was 4.5 newtons when A2 was up. And when A2 is down, F friction is only 1.5 newton. So n changes if the body moves with acceleration up or down because the elevator is moving up or down. But that's all we need to know. F friction now is 1.5 newtons, so we apply 2 newtons. If we apply 2 newtons, means that it's more than this. It's more than this, and we immediately in the realm of kinetic friction, and we have this A2, And we can find this F2 from this equation, right? Very simple. We know that, let's remove it from here. And we're looking for this equation. And this equation would be F minus F friction. And that friction is this mu n. And n is this. So it would be m g minus a1. And this would be m a2, right? All I do, I'm looking for this equation. F first minus F friction. Friction is mu n. Mu is this. N is this. Only in this case it's with minus here. So it's, and that's all. And from this equation we can find A2. A2 equals F minus mu m g minus a1 divided over m. And we can plug the numbers here and we can receive the result. So those were 3 installations of the same problem, and this would be another one. In first case it was all in the elevator that was standing up, no acceleration up. Second case was acceleration up. Result was that n was significantly more. Result of the n significantly more, the friction, this critical friction that divides two scenarios, whether we're in static mode or in kinetic mode, grew up. That's why this 2 and 4 was less than 4.4, and we were not able to move horizontally. It was all static, and when we're going down with acceleration, n is very small because mg overcomes n to create this ma1 in this direction according to this equation along y-axis. And so as a result, we have the n is very small, and so critical friction is 1.4 Newton only. And either 2 or 4 is more than that, and the body, while elevator is going down, the body also slides to the side under the influence of this force. I hope you liked all of this, and there would be another installation of the same problem pretty soon. Thank you very much.